Hi, everyone. Welcome back from this long weekend. I hope that you had some time to relax and hang out with friends and family, socially distanced, of course, in a safe way. We are ready to jump back into what we were learning in geometry. So, today we're going to continue on with parallel slopes and perpendicular slopes. Please make sure you have your notebook, something to write with, and a calculator. If you need to pause the video to grab those materials, please do that. Remember, as you're watching the video, if you need to pause to do any of the work, please just pause the video, take the time to get the notes down. You should be writing things down and doing the examples with me as I do them too to help your learning. So, quick review, parallel slope property, that just tells us that in a coordinate plane, two lines are parallel if their slopes are equal. So we know that if their slopes are equal, then they are going to be, or if they're both vertical lines, then we know that they are going to be parallel. So we might say parallel lines, and we could say equal slopes. Then perpendicular slope property tells us that two non-vertical lines are perpendicular if their slopes are opposite reciprocals. So perpendicular lines, and there's our symbol for that. And we could say that our slopes are like we had A over B, and then negative B over A. Those would be opposite reciprocals. So reciprocal means we flip the fraction, and opposite means if it was positive, then it becomes negative. So that's what that would mean there. For our first example, and you'll want to make sure you get the coordinates down, make sure that you have a coordinate plane. So if you have graph paper, that would be a good idea for this because you're going to be able to see a couple of different ways that we can find the answer, the solution to this problem. So with this problem, it tells us that we have coordinates EF. So E is -3, 0. So I'm going to mark my points on here on my coordinate plane. And again, pause if you need to draw the coordinate plane. I already have mine done, so you might need to pause for this. So here is point E, -3, 0. Point F is 5, -4. Remember, we start at the origin and we go left or right for X and then up or down. So I'm going to go to the right to 5, and I'm going to go down to -4. Now, because I don't have a grid on here, kind of estimating a little bit. So there is point F. And you can go ahead and connect those. I have a line here ready to go on that. Put arrows on the end of your line. Then we have point Q, which is 4, 2. So we go over 4 and go up 2. And here is point Q. Now we need to find the coordinates of point P so that line PQ is parallel to EF. And so remember, parallel means same slope. So we need to first find what is the slope of EF. So I'm going to do slope of EF. Remember that slope is change in y over change in x. So my change in y for EF is going to be 0 minus -4. And then my change in x is -3 minus 5. So my slope is going to be, remember, subtracting a negative is the same as adding a positive. So that's going to be 4 over, and then -3 minus 5, that gives us -8. We do want to reduce that, and we get -1/2. So remember, same slope, parallel. So that means that this line that I'm going to do for PQ must have a slope of -1/2. So there's a couple ways I can do this. One is I can just count. So if my slope is -1 over 2, I can go down 1, and then I can go over 2, and I have a point right there. Or it could be +1 over -2. I can go up 1 and go over 2 to right here. and that would give me another point. So I'm going to have my line right there. So my coordinates, and we could have different answers for this. So my coordinates for P could be, let's see, that would be 6, 1. That would be one choice. Or if I went up 1 and left 2, then it would be 2, 3. I could do this again, go up 1 and over 2 more, and it could be 0, 4. So that would give me my other line. And I have a line here. I'll check and see. And yep, that's pretty good as far as matching up. Put arrows on the end. Now that's one way to do it. So I have all of these options here in green that I just did. Another way to do this would be, and this would actually give me my y-intercept, which we already have right here, but this would give me my y-intercept. So if I go to my slope-intercept form, y equals mx plus b. And now I'm going to use a point, that the point that I have for q, remember that was 4, 2. So I'm going to use 4, 2. That's my x and my y. And then my slope is negative 1/2. I'm going to substitute those in for y, my slope, my x, and that's going to give me my y-intercept. So remember, it's x, then y. So I'll sub in 4 is equal to, my slope is negative 1/2 times x is, oh, sorry, I did that wrong. Y is 2. Sorry about that. X is 4. And then b is what I'm looking for. So 2 is equal to negative 1/2 times 4 is negative 2 plus b, add 2 to both sides, and b gives me 4. So that gives me this 0, 4 right here. My y-intercept is 4. That means x is 0. So that's another point, which we did here just by counting. So if the problem has you do just find the coordinates of point P, you can just count, especially if you have a coordinate grid or have access to that. If you don't have that, you can do this algebraically, and we will practice this part again. Now, moving on towards that and thinking about how we write an equation, I want you to pause the video and I want you to look at each one of these lines, and I want you to write an equation in the form of y equals mx plus b. So you need to know your slope, you need to know your y-intercept. So pause the video and write an equation for each one of these lines. And let's check your work. So let's start with this orange line here. We can see on the orange line that our y-intercept is right here. It's 1, 2, 3, 4. So that's 4. So it's going to be something plus 4. And then our slope, to count our slope, is rise over run. So we can go from this point to this one. We go up 1, 2, 3. So that's up 3 and to the left 1. So the slope is going to be negative 3 over 1 or negative 3. So we should have negative 3x plus 1, 2, 3, that was 4. Negative 3x plus 4. Let's check out this blue one. So on this one, our y-intercept is 2. And if we're counting our slope, we can go from this point to this one. You can choose any of them. We go up 1, 2, 3. So up 3 to the right 1. So our slope is 3. So let's check that. Should be y equals 3x plus 2. And it's just written as 2 plus 3x there, but 3x plus 2 means the same thing. Let's try the red line. So for the red line, looking at our y-intercept is right here at negative 1. And then to count our slope, we're going to go up 2 and over 1. So our slope is 2. So this should be y equals 2x minus 1. Or plus a negative 1. They mean the same thing. And let's try the green one. For the green line, our y-intercept is down here. So it's 1, 2, 3, 4, 5, negative 5. for our y-intercept. And our slope, let's go from this point to this point. I'm just choosing ones that are not, so they're not all jumbled. So we go up 1, 2, 3, so up 3 and over 1, 2. So the slope should be 3 over 2. So we should have 3 over, that's a positive, that's equals right there. So our equations should be y equals 3/2 x minus 5. Or they wrote it as -5 plus 3 over 2x. So there's a little bit of an algebra review for you there, just on how to write equations in slope-intercept form. So now with this problem, it's telling us we have the points 4, 6, and -2, 3, and to find the equation of this line. So ultimately, we are going to use y equals mx plus b. And so to find the equation, we first have to find our slope. Remember, change in y over change in x. So that means we would do 6 minus 3 and 4 minus -2. So we end up with 3 over, remember, subtracting a negative is the same as adding a positive. So 3 over 6, so our slope is 1/2. Remember that we're just finding the equation for this line, so we're not talking about parallel or perpendicular, okay? Now, to find what that y-intercept is, we're going to use the equation y equals mx plus b. We're going to use our slope, and we're going to use one of these points. And I'm going to show you using both points doesn't matter. You'll get the same answer either way. So if we use 0.46, and then we use the slope of 1/2, so we're subbing in y equals mx plus b, just like we did on a previous problem. So 6 goes in for y. Our slope is 1/2 times 4, our x, plus b. So 6 is equal to 2 plus b, and subtract 2, so b is equal to 4. Now let's try this with the other coordinate, because every year we do this, and I know this is a review, you should have done this in algebra, but every year we do this, somebody says, well, doesn't matter which point. So now let's use point D. So we'll do -2, 3. Slope is the same because it's the same line. And subbing in to y equals mx plus b. So in for y, I'm going to sub in 3. My slope is 1/2, and my x is -2 plus b. 3 is equal to -1 plus b. Add 1 to both sides, and b is equal to 4. So we should get the same answer there. If we don't, we did something wrong. So because this is on the same line, they should have the same y-intercept. Now, to write our equation, we just sub in for slope and y-intercept. X and y are unknowns here. So y is equal to 1/2 x plus 4. And that would be how you would write your equation given the 2 points on the line. Again, that should also be review for you. Now here's something that we're going to add a little bit of a twist to it. Now we're going to find the equation of the perpendicular bisector of a segment with these two endpoints, 2, 9, and -6, -7. So we know when we're talking about perpendicular opposite reciprocal slopes. So let's first find the slope of 2, 9 and -6, -7. So again, change in y over change in x. So we'll do 9 minus -7 over 2 minus -6. Remember, subtracting a negative is the same as adding a positive. So you end up with 16 over 8 or 2. That's going to be your slope. Now, we need the y-intercept of this line because we want to be able to find, again, we're looking for ultimately the perpendicular bisector of this segment. So we're just going to use 0.29 and the slope of 2. And we're going to find the y-intercept. So we'll put 9 in for y, 2 in for your slope, 2 in for x, plus b. 9 equals 4 plus b, and b will give you 5. So your y-intercept is 5, okay? Now, let's go to the next part. Now, because this says bisector, that means that bisector means it cuts it in half, And a word that we used for that was midpoint, something that we learned, right? So we need to know the midpoint of this segment right here, that's made up by the endpoints 2, 9, and negative 6, 7. So remember, to find the endpoint, we do x sub 1 plus x sub 2 divided by 2, and then y sub 1 plus y sub 2 divided by 2. And it's going to give us another set of coordinates. So to find our midpoint, we're going to add our x's together. So 2 plus negative 6, then we'll end up dividing it by 2. And then we add our y's together, 9 plus negative 7, and we divide that by 2. So when we do that, we end up with negative 4 over 2 and 2 over 2. And then we want to reduce that, and we end up with negative 2, 1. This is our midpoint. We're going to hang on to that. Now, to find the equation of the line for the perpendicular bisector, we are going to use our midpoint, and then we also need to know the perpendicular slope. So from that 2, the perpendicular slope is going to be negative 1/2. So subbing in y equals mx plus b, we're going to use our negative 2, 1, so 1 goes in for y. In for my slope is negative 1/2, and in for x is negative 2 plus b. 1 is equal to 1 plus b, and b is equal to 0. So my y-intercept is 0. So when I go to write my equation for this, I'm going to have y is equal to, my perpendicular slope is negative 1/2 x plus my y-intercept is 0, or just y equals negative 1/2 x. Now I'm looking at this problem and I'm saying I actually did not even need my y-intercept over here, so I just did a little bit extra work I didn't need to do this part. This is ultimately what we needed to find. So make sure that you have these examples down. Make sure that you're showing all of your work. And if you have any questions, please come to the asynchronous class time. And I hope you have a good rest of your day.